We get 1/10 when we divide 1 by 10. So here we have one big rectangle, and if we divide it into 10 pieces and keep only one of those pieces, we have 1/10. We can write 1/10 as a decimal. That's 0.1. So the digit after the decimal point is the tenths digit. So what we've shown here is that 1 divided by 10 equals 0.1, or 1 whole divided by 10 is 1/10. We get 1/100th when we divide 1 by 100. So again, we've got one big rectangle, and if we divide that into 100 pieces and keep only one piece, then we have 1/100th. So we can write 1/100th as a decimal as well. That's 0.01. Remember, the first digit after the decimal point tells us how many tenths we have, and then the second digit after the decimal point tells us how many hundredths we have. So what we've shown here is that 1 divided by 100 equals 0.01, or 1 whole divided by 100 equals 1/100th. We can also get 1/100th when we divide 1/10 by 10. So in this rectangle, we can see that one part out of 10, or 1/10, is shaded. If we divide this shaded part into 10 and keep only 1/10, then you can see that we have 1/100th. We have the same amount of the rectangle shaded as we did on the previous page. So 0.1 divided by 10 equals 0.01, or 1/10 divided by 10 is 1/100th. So we know our place values for thousands, hundreds, tens and ones. Then we have a decimal point to separate our ones from our tenths, and now we know that the place value after the tenths is the hundredths place. So we know that if we have 1,000, that's the same as having 10 hundredths. If we have 100, that's the same as having 10 tens. 1/10 is the same as 10 ones, but this carries on into decimal place values as well. So if we have 1/1, that's the same as having 10 tenths. And then if we have 1/10, that's the same as having 10 hundredths. We can also go the other way. So if we've got 10 hundredths, we know that's the same as 1,000. 10 tens is the same as 100. 10 ones is the same as 1/10. And we carry on in the same way going into decimal place values. So if we have 10 tenths, that's the same as having 1/1. And if we have 10 hundredths, that's the same as having 1/10. So here we've got two different fraction bars. The top fraction bar is split into 100 pieces, so shows us hundredths, and then the fraction bar below is split into 10 pieces, so shows us tenths. So 1/100th is one part out of 100. We can count on 2 hundredths, 3 hundredths, and you get the idea, so I'll skip through. 9 hundredths. Then, if we've got 10 hundredths, we can see that that's the same as having 1/10. We've got the same amount shaded in both of our rectangles. So we can say that 10 hundredths and 1/10 are equivalent fractions. Now if we count on, you can see that 11 hundredths is just a little bit more than 1/10. And we can keep on counting, but you'll notice that when we get to 20 hundredths, that's the same as having 2/10. And we could keep on counting, so when we get to 30 hundredths, that's 3/10. You'll notice 39 hundredths is actually just a little bit less than 4/10. So if we have 40 hundredths, we have a fraction equivalent to 4/10. And I'm not going to go through the rest because I think we get the idea. So if you've got 100 hundredths, you've got 1 whole. And if you've got 10/10, again, you've got 1 whole. Now here, we need to convert decimals into fractions with a denominator of 100. So first, we have 0.9. We know that the first digit after the decimal point tells us how many tenths we have. So 0.9 is 9/10. But we need a fraction with a denominator of 100. So we need to find an equivalent fraction. To do that, we use multiplication, and 10 times 10 is 100, and what we do to the denominator, we need to do to the numerator as well, and 9 times 10 is 90, so our numerator is 90. Now we have 0.4. Again, the first digit after the decimal point tells us how many tenths we have, so that's 4/10. We need a denominator of 100, and 10 times 10 is 100. So, to get our numerator, we need to multiply 4 by 10, and that gives us 40. To show what we were doing here, we had 0.9, which is 9/10. But if we take our fraction bar and instead split it into 100 pieces, we have 90 hundredths. And with 0.4, we have 4/10, but if we split the fraction bar into 100 pieces, we have 40 hundredths. We can also show what we did using place value counters. So, because the first digit after the decimal point is the tenths digit, with 0.9, we have 9/10. But each of those tenths can be exchanged for 10 hundredths, so that gives us 90 hundredths altogether. And with 0.4, we have 4/10, but if we change those tenths into hundredths, we get 40 hundredths. Now we have 0.02. Remember, the first digit after the decimal point tells us how many tenths we have, and we don't have any tenths because we have a 0, and then the second digit after the decimal point tells us how many hundredths we have, so here we have 2 hundredths. Now for 0.09, again the second digit after the decimal point tells us how many hundredths we have, so we have 9 hundredths. And we can represent 0.02 or 2 hundredths as 2 parts out of 100 on a fraction bar. And we can represent 0.09 or 9 hundredths as 9 parts out of 100. We could also show 2 hundredths using 2 place value counters for hundredths, or 9 hundredths as 9 hundredths place value counters. Now we have 0.12. So we know that the first digit after the decimal point tells us how many tenths we have, and the second digit after the decimal point tells us how many hundredths we have. But our answer isn't 2 hundredths because we can change the 1/10 into hundredths as well. 0.12 is actually 12 hundredths. What we can do, if we see a number with 2 decimal places, we can draw a line across from the decimal point and write a denominator of 100. That's because we had 2 digits after the decimal point, and the second digit after the decimal point has a hundredths place value. To make it a bit clearer, let's think what 0.12 really means. The 1 is in our tenths place value column, and the 2 is in our hundredths. If you put that together, you get 12 hundredths. That's because we can find an equivalent fraction for 1/10, which has a denominator of 100. 1/10 is the same as 10 hundredths, because 10 times 10 is 100, and 1 times 10 is 10. So if you add the 2 hundredths to that, you get 12 hundredths. Now we have 0.99. That's 99 hundredths because, again, we have a number with 2 decimal places, and we know that the second digit after the decimal point tells us how many hundredths we have. So we can draw a line across from our decimal point and a denominator of 100. To make it clear, this 9 stands for 9/10 because it's the first digit after the decimal point, and this 9 stands for 9 hundredths. That gives us 99 hundredths because 9/10 is the same as 90 hundredths. 10 times 10 is 100 and 9 times 10 is 90. So when we add the 9 hundredths to the 90 hundredths, we get 99 hundredths. To make it clear what's happening, we can show 0.12 as 1/10 and 2 hundredths. But if we want to show that as a fraction with a denominator of 100, we can split our fraction bar into 100 pieces, and we can see that we have 12 pieces, because the 1/10 is the same as 10 hundredths. And for 0.99, we can show 9/10 and 9 hundredths. But if we want to show a fraction with a denominator of 100, we can split our fraction bar into 100 equal pieces, and we can see that we have 99 pieces. That's because the 9/10 is the same, or is now, 90 hundredths. We can also show this using place value counters. So for 0.12, we have 1 in our tenths and 2 in our hundredths. But the 1/10 is the same as 10 hundredths. So now, altogether, we have 12 hundredths. And with 0.99, we have 9/10 and 9 hundredths. But each of our tenths can be exchanged for 10 hundredths, giving us 99 hundredths altogether. So for this first question, we have 20 hundredths, and we need to find an equivalent fraction with a denominator of 10 and write the fraction as a decimal. So first, let's take our 20 hundredths and see if we can find an equivalent fraction with a denominator of 10. Remember, as well as multiplication, we can use division to find equivalent fractions, and 100 divided by 10 is 10. When we're finding equivalent fractions, what we do to the denominator, we need to do to the numerator as well, and 20 divided by 10 is 2. So 20 hundredths is equivalent to 2 tenths. We can write 20 hundredths as 0.20. So because there's a denominator of 100, we need 2 digits after the decimal point. But we've seen that 20 hundredths is equivalent to 2 tenths. So we can write 2 tenths as 0.2. We don't need zeros on the end of decimal numbers, because all the 0 told us is that we had something equivalent to 2 tenths and 0 hundredths, but 0.2 tells us this as well. Now we have 60 hundredths. First, let's find an equivalent fraction with a denominator of 10. 100 divided by 10 is 10, and what we do to the denominator, we do to the numerator as well, and 60 divided by 10 is 6. So 60 hundredths is equivalent to 6 tenths. If we're writing this as a decimal, we could write 0.60 because that's 60 hundredths. The denominator of 100 tells us that we need to use 2 places after the decimal point. But if there's a 0 on the end of a decimal, we don't need it. We can just write 0.6. And we've seen that because 60 hundredths is equal to 6 tenths, and the first digit after the decimal point is our tenths digit. So let's show what we've done here. First, we had 20 hundredths, but we saw that that was equivalent to 2 tenths. So, as a decimal, we could write that as 0.2. Then we had 60 hundredths, but we saw that that was equivalent to 6 tenths, so in decimal form could be written as 0.6. We can also show what we've done using place value counters. So for this first question, we started with 20 hundredths, but remember, 10 hundredths can be exchanged for 1 tenth. That gives us 2 tenths, or 0.2, as a decimal. Then we had 60 hundredths, but 10 hundredths can be exchanged for 1 tenth. So when we've exchanged all of our hundredths for tenths, we get 6 tenths, which can be written as 0.6. We need to partition these decimals into tenths and hundredths, showing the partition as both fractions and decimals. So first, we have 0.47. We know that the first digit after the decimal point tells us how many tenths we have, so that's 4 tenths. And then the second digit after the decimal point tells us how many hundredths we have, so we have 7 hundredths. We can also write the partition in decimal form. So 4 tenths is 0.4 as a decimal because the first digit after the decimal point shows tenths, and then 7 hundredths is 0.07 as a decimal because the second digit after the decimal point is the hundredths digit. Now let's partition 0.61. Again, the first digit after the decimal point tells us how many tenths, so that's 6 tenths. And then the second digit after the decimal point tells us how many hundredths, so that's 1 hundredth. We can write the partition in decimal form as 0.6 because that shows 6 tenths, and 0.01 because that shows 1 hundredth. We can show what we did here. So for the first question, we had 0.47, so that's 47 hundredths, but 47 hundredths is the same as 4 tenths plus 7 hundredths, or 0.4 plus 0.07. Then we had 0.61, or 61 hundredths, but that's the same as 6 tenths and 1 hundredth, or 0.6 plus 0.01. We could also show the place value counters. With 0.47, we have 4 tenths and 7 hundredths. With 0.61, we have 6 tenths and 1 hundredth. In these questions, we're adding hundredths to tenths. So first we have 0.2 plus 0.02. We can set this out as a column addition, but we need to make sure that our decimal points are lined up, because if our decimal points are lined up, then our ones, tenths, and hundredths columns will be lined up as well. We can write 0 in empty squares, because we haven't changed the question. If we have 0.2, that's 2 tenths, but all writing a 0 here tells us is that we don't have any extra hundredths. We can copy the decimal point down into our answer, and now we can add using column addition. So 0 plus 2 is 2, 2 plus 0 is 2, and 0 plus 0 is 0. So our answer is 0.22. Now we have 0.5 plus 0.06. Again, we can write the numbers out, making sure that the decimal points are lined up, so that our ones, tenths, and hundredths columns are lined up as well. We can write 0 in this empty square, and copy the decimal point down into our answer. Now, 0 plus 6 is 6, 5 plus 0 is 5, and 0 plus 0 is 0, so our answer is 0.56. Let's have a think about how this works. For this first question, we started with 0.2, so that's 2/10, and we were adding 0.02, so that's 2/100ths. If we turn our 2/10 into 20/100ths, that's kind of what we did by putting the 0 on the end. And then when we add, we put things together. So now we can see that we have 22/100ths, which we write as 0.22. Now for this question, we started with 0.5, so that's 5/10, and we were adding 0.06, so that's 6/100ths. 5/10 is the same as 50/100ths, and when we add the 6/100ths, we get 56/100ths, or 0.56. We can also show the addition using place value counters. So 0.2 is 2/10, and we're adding 0.02, so that's 2/100ths. What do we have altogether? Well, we've got 2/10 and 2/100ths, so 0.22. And for this question, we started with 0.5, so that's 5/10, and we were adding 0.06, so that's 6/100ths. Put those together, and we have 5/10 and 6/100ths, or 0.56. Now we're subtracting hundredths from tenths. So first we have 0.2 minus 0.02. We can write this out as a column subtraction, making sure that the numbers are written out with the decimal points lined up, because if the decimal points are lined up, then the ones, tenths and hundredths columns will be lined up as well. Now we have an empty square here, but we can write a 0 in this empty square, because you can always write a 0 on the end of a decimal without changing the number. So 0.2 tells us that we have 2/10, but all the 0 on the end tells us is that we don't have any extra hundredths, so 0.20 is the same as 0.2. Now we can copy the decimal point down into our answer and subtract using column subtraction. We can't do 0 minus 2, so we go to the left, 1 less, 1 in front. 10 minus 2 is 8, 1 minus 0 is 1, and 0 minus 0 is 0. So our answer is 0.18. Now we have 0.5 minus 0.06. So again, we write the numbers out with the decimal points lined up. We can write a 0 in this empty square because 0.50 is the same as 0.5, so we haven't changed the question. But now we can copy the decimal point down into our answer and subtract using column subtraction. We can't do 0 minus 6, so we go to the left, 1 less, 1 in front. 10 minus 6 is 4, 4 minus 0 is 4, and 0 minus 0 is 0. So that gives us 0.44. So let's think about what we did here. We started with 0.2, so that's 2/10. But if we change those tenths into hundredths, we have 20/100ths, so we could write 0.20. So now, when we're taking away 2/100ths, that leaves us with 18/100ths, or 0.18. And for this question, we started with 0.5, so that's 5/10. But 5/10 is the same as 50/100ths, so when we take away 6/100ths, that leaves us with 44/100ths, or 0.44 as our answer. We can also show the subtraction using place value counters. So with 0.2, we have 2/10, but we want to take away 2/100ths. To do that, we need to exchange one of our tenths for 10/100ths. That's why we did the exchanging to show 1/10, and that gave us 10/100ths. So when we took away 2/100ths, we were left with 1/10 and 8/100ths, or 0.18. Then, for this question, we started with 0.5, so 5/10ths, but we wanted to subtract 6/100ths. So we exchange one of our tenths for 10/100ths. That meant that we could subtract 1, 2, 3, 4, 5, 6/100ths to give us 4/10ths and 4/100ths, or 0.44. Now we have 0.45 minus 0.3. Again, we need to write the numbers out with the decimal points lined up, because if the decimal points are lined up, all the other place values in the question will be lined up as well. Now we can write a 0 in this empty square, because 0.30 is the same as 0.3. Now we copy the decimal point down into our answer. 5 minus 0 is 5, 4 minus 3 is 1, and 0 minus 0 is 0. So we get 0.15. Now we have 0.58 minus 0.5. We have our decimal points lined up. We can write a 0 in this empty square and copy the decimal point down into our answer. 8 minus 0 is 8, 5 minus 5 is 0, and 0 minus 0 is 0. So we get 0.08. Again, we can show what we did. We started with 0.45, so that's 4/10ths and 5/100ths. We were subtracting 0.3, so if we take away 3/10ths, that leaves us with 1/10 and 5/100ths, or 0.15. We could also show 1/10 and 5/100ths as 15/100ths. Then we had 0.58, so 5/10ths and 8/100ths, and we were subtracting 0.5. So if we subtract 5/10ths, that leaves us with just 8/100ths, or 0.08. We can also show the subtraction using place value counters. With 0.45, we have 4/10ths and 5/100ths. Subtracting 0.3 means taking away 3/10ths, so that leaves us with 1/10 and 5/100ths. Then we had 0.58, so 5/10ths and 8/100ths, and subtracting 0.5 means taking away 5/10ths. That leaves us with just 8/100ths. Now let's practice counting in tenths or hundredths. So first we have 0.62, 0.63, then 0.64. So what are the next 7 numbers going to be? Well, let's show them. You can see counting in hundredths isn't much more difficult than counting in ones. The only thing we need to spot is that we don't usually write zeros on the end of decimals. So instead of 0.70, we would normally just write 0.7. And let's show the counting using place value counters. So 0.62 means we have 6/10ths and 2/100ths. We can carry on adding hundredths, but now we have 10/100ths, and we exchange 10/100ths for 1/10. So now we have 7/10ths. That's why we write 0.7, and then we just count on one more hundredth. Now 0.05, 0.15, 0.25. What are our next 7 numbers? Well, we can see that here we're counting in tenths, and you'll notice counting in tenths isn't much more difficult than counting in tens. So, on our place value counters, we can just see that we're adding 1/10 each time. Now, 0.94, 0.95, 0.96. What are our next 7 numbers? Well, we're adding hundredths or counting in steps of 1/100th, and you can see that counting in hundredths is very similar to counting in ones, but we don't normally write 1.00 because if you have a decimal point and then zeros on the end of a number, you have a whole number. So notice we get 0.99, then 1 whole, then 1.01. And let's see why we get that. So to start with, we had 0.94, so 9/10ths and 4/100ths. Then we were counting in hundredths. But when we got to 10/100ths, we could exchange those 10/100ths for 1/10. And then, if we put our tenths together, you can see that we now have 10/10ths. So we can exchange those 10/10ths for 1 whole. And that's why we get 1. And then we just kept on adding hundredths until 1.03. Now 0.49, 0.59, 0.69. What are our next 7 numbers? Well, you can see that we're counting in tenths. So, showing our place value counters, we start with 0.49, so 4/10ths and 9/100ths, and we're counting in tenths. But now we have 10/10ths, and to see why that's 1.09, what we're doing is changing those 10/10ths into 1 whole. So that's 1 whole and 9/100ths, or 1.09. And then we can keep on counting in tenths up to 1.39. Now 3.47, 3.48, 3.49. What are our next 7 numbers? Well, we're counting in hundredths, and we can see 3.50 is usually just written as 3.5 because we don't need zeros on the end of decimal numbers. And we can see the counting with place value counters because we started with 3.47, so that's 3 wholes, 4/10ths and 7/100ths, and we're counting in hundredths. But when we get to 3.5, we can change those 10/100ths for 1 extra tenth, and then continue counting in hundredths. Now 2.61, 2.71, 2.81. What are the following numbers? Well, we can see that here we're counting in tenths, and showing this with place value counters, we start with 2.61, so 2 wholes, 6/10ths and 1/100th, and we're counting in tenths. When we've got 10/10ths, we can exchange those 10/10ths for 1 more whole, so that gives us 3 ones and 1/100th, or 3.01, and then we can keep on counting in tenths up to 3.51. Now let's practice counting backwards in tenths or hundredths. So first we have 0.16, 0.15, then 0.14. So what are the next 7 numbers in this sequence? Well, we can see that we're counting back in hundredths because it's the hundredths digit that's changing. The only thing we need to change is 0.10 because we don't usually write zeros on the end of decimals. For 0.10, all this 0 tells us is that we don't have any hundredths, but 0.1 tells us this as well, so we don't need to write zeros on the end of decimals. So let's think about this question, and let's show place value counters so that we can understand what's happening. We start with 0.16, so that's 1/10th and 6/100ths. We're taking away 100th each time, so then we get to 0.1 or 1/10th. But to keep on counting back in hundredths, we need to exchange our tenth for 10/100ths, and then we can continue counting back until we get to 0.07 or 7/100ths. Now 1.05, 1.04, 1.03. What are the next numbers in this sequence? Well, again, we're counting back in hundredths, and you can see that counting back in hundredths isn't much more difficult than counting back in ones. The only thing we need to change is 1.00, because if you have a decimal point and then zeros on the end of a number, you have a whole number. So 1.00 would usually just be written as 1. And again, we can show place value counters to see what's happening. We start with 1.05, so that's 1 whole, no tenths, and 5 hundredths. We're counting back in hundredths, but when we get to 1 whole, we need to exchange our 1 whole for 10 tenths, and then, because we're counting back in hundredths, we need to take one of those tenths and exchange it for 10 hundredths. So now we can keep on counting back in hundredths until 0.96, or 9 tenths and 6 hundredths. 3.25, 3.24, then 3.23. So what comes next? Again, we're counting back in hundredths, but rather than writing 3.20, we can just write 3.2, because all the 0 tells us is that we don't have any hundredths, but 3.2 also tells us this. We don't need zeros on the end of decimals. Again, we can use place value counters to see what's happening. We start with 3.25, so that's 3 wholes, 2 tenths, and 5 hundredths. We're counting back in hundredths, so when we get to 3.2, we have 3 wholes and 2 tenths. But to count back in hundredths, we need to take one of our tenths counters and exchange it for 10 hundredths counters. Then we can keep on counting back in hundredths until we get to 3.16, or 3 wholes, 1 tenth, and 6 hundredths. Now 3.25, 3.15, 3.05. What are the next 7 numbers in this sequence? Well, this one's slightly different because we're counting back in tenths rather than in hundredths. But again, we can use place value counters to see what's happening. 3.25 is 3 wholes, 2 tenths, and 5 hundredths, and this time we're counting back in tenths, so the 5 hundredths is going to stay the same. When we've taken away 2 tenths, we get to 3.05, or 3 wholes and 5 hundredths, but then, to take away tenths, we need to exchange one of our wholes for 10 tenths. Then we can keep on subtracting tenths, or counting back, until we get to 2.35, or 2 wholes, 3 tenths, and 5 hundredths. Now we're going to write decimals on a number line. So on this number line, we have 0.3, 0.4, and 0.5 labelled. But we have 10 lines between 0.3 and 0.4. Now we know that between tenths, we have hundredths. 10 hundredths make 1 tenth. So these smaller lines must show hundredths. Now the easiest thing to do is to write 0.3 as 0.30 and do the same, putting a 0 on the end of 0.4 and 0.5. We haven't changed the decimal because remember, a 0 on the end of a decimal doesn't change the number. But now, if we want to find values on our number line, they're easier to work out. So, what number is this line pointing to? Well, it's past 0.3 and it's 2 lines in, so that's 0.32. Here we have 0.39 because it's past 0.3 and it's 9 lines across. Here we have 0.42 because it's past 0.4 and 2 lines across. So what do we have here? We have 0.48. It's past 0.4 and it's 8 lines across. So notice 0.48 is less than 0.5. Now, on this number line, we have 1.6, 1.7, and 1.8. Again, what I like to do is to write zeros on the end of our decimals. So then, if we need to find a specific value, it's easier for us to work out. This line is pointing to 1.63 because we're 3 lines after 1.6. Here we have 1.68, then 1.74 because we're 4 lines after 1.7, and here we have 1.77. Now this number line is slightly different. We have 0 and our tenths and 1 as our labelled values. Again, we can put zeros on the end, and if we've got a whole number, we can write 0.00 on the end. So we can do that with 0 and 1. So what number is the arrow pointing to? Well, between 0.1 and 0.2, we have 0.15. That's right in the middle, and it makes sense if you think that 15 is right in the middle of 10 and 20. So where is the arrow pointing to now? Well, this is 0.45. That's right in the middle of 0.4 and 0.5. Now we have 0.65, and here the arrow is pointing right in the middle of 0.9 and 1, so that's 0.95, and that makes sense because 95 is right in the middle of 90 and 100. Now for this number line, we have 0, 1 and 2, so we have whole numbers labelled, and this 0.5 tells us that each of these lines must be 1/10, because 0.5 is 5 lines after 0. Again, we can put zeros on the end of decimals without changing them, and if we have whole numbers, we can always write 0.00 on the end, because that will help us work out the values that we need. So which number is the arrow pointing to here? That's 0.45, because remember, each of these lines is 1/10, and so this line here is 0.4, we have 0.5 labelled, so right in the middle we have 0.45. Here we have 0.95, that's right in the middle of 0.9 and 1 whole. What number is the arrow pointing to now? Well, that's 1.35, because this line here is 1.3, the line after the arrow is 1.4, and the arrow is right in the middle, so that's 1.35. And where is the arrow pointing to now? Well, we have 0 and 0.1, so right in the middle we have 0.05. That's right in the middle of 0 and 0.1, because that's equivalent to 5 hundredths. And if we double 5 hundredths, we have 10 hundredths, and that would be 1/10. So now onto our last number line. Again, it's easier to find values if we write zeros on the end of our decimals, and if we have whole numbers, we can always write 0.00 on the end, so that we have 2 digits after the decimal point, just like we have with all of our other values. So where is the arrow pointing to here? Well, we can see that the arrow is now not right in the middle. The arrow is closer to 0.2 than 0.1. So I would estimate that the arrow is pointing to 0.18, or perhaps 0.17 or 0.19, but definitely more than 0.15. So where is the arrow now? It's closer to 0.4 than 0.5, so I would estimate it's at 0.43 or perhaps 0.42. Here, the arrow is pointing to 0.58 because it's closer to 0.6 than to 0.5. And finally here, we can see the arrow is almost in the middle of 0.9 and 1, but perhaps just slightly closer to 1. So I would estimate 0.96. Now in these questions, we need to compare decimals which have a different number of decimal places. So first, we have 0.2 and 0.33. The way to compare decimals is to write out both numbers with the decimal points lined up, and then to write 0 in empty squares. And we can do that because 0.20 is the same as 0.2. All this 0 tells us is that we don't have any hundredths. So now it's easier to compare. We start by comparing the larger place values. So here, both numbers have 0 in the ones, but if we go along to the tenths, we have 2/10 and 3/10, so we know straight away that this number with 3/10, 0.33, is the larger decimal, and we didn't even need to look at the hundredths place value. As soon as we saw that the tenths was larger in this number, we knew which was the larger decimal. Now we have 0.9 and 0.99. So again, we write out both numbers with the decimal points lined up, write 0 in empty squares, and now we compare the larger place values first. So both numbers have 0 ones and 9/10. But 0.9 has 0 hundredths and 0.99 has 9. So 0.99 is the larger decimal. Now we have 0.5 and 0.45. Again, we write the numbers out with the decimal points lined up, and we need to write a 0 in this empty square. Now both numbers have 0 ones, but if we look to the tenths, we have 5 and 4, so we know straight away that the number with 5/10 must be larger, so that's 0.5. And it's easy to get confused on this question, because with 0.45, we have 2 digits after the decimal point. But remember, the first digit always tells us how many tenths we have, and tenths are 10 times larger than hundredths. So it doesn't matter that this number has 5 hundredths, because 0.5 has an extra tenth. Now 0.55 and 0.7. We write the numbers out with the decimal points lined up and write 0 in empty squares. Both numbers have 0 ones, but if we look to the tenths, we have 5 and 7. So we know straight away that this second number with 7/10 is our larger number. So let's think back to this first question. We had 0.2, and we know that the first digit after the decimal point is the tenths digit, so we can show 2/10. Then we had 0.33, so that's 3/10 and 3/100, which we can show on our fraction bar. And we can see clearly that 0.33 is the larger decimal because a larger amount of the fraction bar is shaded. We could also show place value counters, so with 0.2 we have 2/10, and with 0.33 we have 3/10 and 3/100. Next we had 0.9, so that's 9/10, and 0.99, so that's 9/10 and 9/100. We can see that 0.99 is larger, and if we show place value counters, we have 9/10 with 0.9, but 9/10 and 9/100 with 0.99. Next we had 0.5 and 0.45. So with 0.5 we have 5/10, but with 0.45 we only have 4/10, and although we have 5/100, because hundredths are so much smaller than tenths, 0.5 is our larger decimal. Showing place value counters, we have 5/10ths, and with 0.45, we have 4/10ths and 5/100ths. So although we've got more counters, we need to remember that we need 10/100ths to have the same value as 1/10th. So the extra tenth in 0.5 means that it's the larger decimal. Then 0.55, so 5/10ths and 5/100ths, and 0.7, so 7/10ths. We can see that 0.7 is larger. With place value counters, for 0.55, we can show 5/10ths and 5/100ths, and with 0.7, we can show 7/10ths. So, for this first number, because we only have 5/10ths, it doesn't matter how many hundredths we have, 0.7 is our larger decimal. Now we have 7.65 and 7.69. If we write the numbers out, one below the other, with the decimal points lined up, we can see that both have 7 ones, both have 6/10ths, but then when we look at the hundredths, we can see that this number with 9/100ths must be larger, so that's 7.69. Next, we have 4.71 and 4.69. Both numbers have 4 ones, but if we look at the tenths, we can see that the number with 7/10ths, so 4.71, must be larger, and it doesn't matter that the second number has more hundredths, because tenths are larger than hundredths. Now we have 6.01 and 5.99. So remember, we start by comparing the larger place values, so here that's comparing the ones. In the first number we have 6 ones, and in the second we only have 5, so we know straight away that this first number, 6.01, must be larger. It doesn't matter that with 5.99 we have more tenths and more hundredths, because tenths and hundredths are smaller than ones. Now we have 5.45 and 5.5, so we write out both numbers with the decimal points lined up, but here we need to remember to write 0 in our empty square. Now both numbers have 5 ones, but the first number only has 4/10ths and the second number has 5/10ths, so 5.5 is our larger decimal. We can show what we were comparing with place value counters. So 7.65 is smaller than 7.69 because 7.65 only has 5/100ths and 7.69 has 9/100ths. 4.71 is larger than 4.69 because both numbers have 4 ones, but because the first number has 7/10ths, that's larger than any number with only 6/10ths. It doesn't matter that here we have 9/100ths and here we only have 1, because remember, we need 10/100ths to make something with the same value as just 1/10th. Then we had 6.01 and 5.99. 6.01 is larger because ones are larger than tenths, so it doesn't matter that we've got 9/10ths and 9/100ths, because even 9/10ths and 9/100ths taken together have less value than 1 whole. So, because this number has more ones, we know straight away that it's our larger number. Finally, we had 5.45 and 5.5. 5.5 is larger because although the first number has 5/100ths, hundredths are smaller than tenths. We need 10/100ths to make something with the same value as 1/10th. So, because the second number has an extra tenth, we know that 5.5 is the larger number. Now for these questions, we need to add decimals with a different number of decimal places. So first, we have 6.1 plus 2.35. We can write this out as a column addition But we need to be really careful to make sure that both numbers are written out with the decimal points lined up, because if the decimal points are lined up, then our ones, tenths and hundredths place value columns will be lined up as well. Now we have an empty square, so we can write zeros in empty squares, and that works because 6.10 is the same as 6.1. All the 0 tells us is that we don't have any hundredths in this number. The other thing that we need to remember to do is to copy the decimal point down into our answer, and I like to do that first so that I don't forget. Now with column addition, we work from right to left. So 0 plus 5 is 5, 1 plus 3 is 4, and 6 plus 2 is 8. So our answer is 8.45. Now we have 5.3 plus 1.95. So the numbers are written out with the decimal points lined up. We can write a 0 in this empty square, and we need to remember to copy the decimal point down into our answer. Now we add using column addition. So 0 plus 5 is 5, 3 plus 9 is 12, so 1, 2, and 1 plus 5 plus 1 is 7, so that gives us 7.25. Finally, we have 56.38 plus 24.7. So the numbers are written out with the decimal points lined up. We can write a 0 in this empty square and copy the decimal point down into our answer. Now 8 plus 0 is 8, 3 plus 7 is 10, so 1, 0, 1 plus 6 plus 4 is 11, so 1, 1, and 1 plus 5 plus 2 is 8. That gives us our answer of 81.08. Now, let's look back to this first question and think about what we did. We started with 6.1, so that's 6 ones and 1/10. To add 2.35, first we added the 5 hundredths, so we can add 1, 2, 3, 4, 5 hundredths place value counters. Then we added 3/10, and finally we added 2 ones. That gave us 8.45, so 8 ones, 4/10, and 5 hundredths. Next we had 5.3, so 5 ones and 3/10, and we were adding 1.95. First of all, we added 5 hundredths, so let's count 1, 2, 3, 4, 5 hundredths place value counters. Then we added 9/10, but adding 9/10 meant that we had 12/10, so we exchanged 10 of those tenths for an extra whole and had 2/10 in our answer. And we can see how this works. If we add 1, 2, 3, 4, 5, 6, 7, 8, 9, so we've added 9/10, and you'll notice that when we got 10/10, we exchanged those for one whole. So now we just add one more 1, and that gives us 7 ones, 2/10, and 5 hundredths, so 7.25. Finally, we had 56.38, so 5/10, 6 ones, 3/10, and 8 hundredths, and we were adding 24.7. So we didn't need to add any hundredths, so kept the 8 hundredths in our answer. Then we moved on to the tenths column, and we needed to add 7/10. If we add 1, 2, 3, 4, 5, 6, 7/10, now we have 10/10, but we can only have one digit in each place value, so we need to exchange those 10/10 for one extra whole. Then we added 4 ones, so we can add 1, 2, 3, 4 ones, but now we have 11 ones, so we can exchange 10 of those ones for one extra 10. And then finally, we just added 2 more 10s. That gave us 81.08 because we have 8 10s, 1 1, 0 tenths, and 8 hundredths. Now, for these questions, we need to be able to subtract decimals with a different number of decimal places. So first, we have 31.8, and we need to subtract 6.45. So the number we're subtracting has 2 decimal places, and the number we're subtracting from only has 1 decimal place, so only has tenths, not hundredths. We can subtract using column subtraction, but we need to make sure that we write out the numbers with the decimal points lined up. That way, our other place values, so our tens, ones, tenths, and hundredths place value columns, will be lined up as well. Now we have an empty square, so we can write a 0 here, because 31.80 is the same as 31.8. All the 0 tells us here is that we don't have any hundredths. Now we need to remember to copy down the decimal point into our answer, and I like to do this first so that I don't forget. Now we can subtract using column subtraction. So 0 minus 5 we can't do, so we go to the left, 1 less, 1 in front, and 10 minus 5 is 5. 7 minus 4 is 3. We can't do 1 minus 6, so we go to the left, 1 less, 1 in front. 11 minus 6 is 5, and 2 minus nothing is 2. That gives us 25.35. Now we have 26.8, and we need to subtract 6.12. So we write the numbers out with the decimal points lined up so that our place values are lined up as well. We can write 0 in this empty square, and we need to remember to copy the decimal point down into our answer. Now we subtract using column subtraction. We can't do 0 minus 2 using the column method, so we go to the left, 1 less, 1 in front. 10 minus 2 is 8. 7 minus 1 is 6. 6 minus 6 is 0, and 2 minus nothing is 2. So our answer is 20.68. Now we have 125.48, and we're subtracting 72.3. So it's really important here that we have our decimal points lined up so that the other place values in our question are lined up as well. We can write a 0 in this empty square because 72.30 is the same as 72.3. All this 0 tells us is that we don't have any hundredths in this number. We copy down the decimal point into our answer. Now 8 minus 0 is 8, 4 minus 3 is 1, 5 minus 2 is 3. We can't do 2 minus 7, so go to the left, 1 less, 1 in front. 12 minus 7 is 5, and 0 minus nothing is 0. So our answer is 53.18. So let's look back to this first question and think about what we did here. We had 31.8, so that's 3 tenths, 1 1, and 8 tenths. We needed to subtract 6.45. So first, we subtracted 5 hundredths, but to do that, we needed to exchange one of our tenths for 10 hundredths. So we can take one of our tenths place value counters and exchange it for 10 hundredths. We can subtract 1, 2, 3, 4, 5, and then we had to subtract 4 tenths, so we can take away 1, 2, 3, 4 of our tenths place value counters. Finally, we needed to subtract 6 ones, but to do that, we needed to exchange one of our tens for 10 more ones. So, to subtract 6, we can subtract 1, then exchange, and subtract 2, 3, 4, 5, 6. We didn't need to subtract any tens, so we have our answer 25.35. So that's 2 tenths, 5 ones, 3 tenths, and 5 hundredths. The next question we did was 26.8, so 2 tenths, 6 ones, and 8 tenths, and we needed to subtract 6.12. First, we subtracted 2 hundredths, but to do that, we exchanged one of our tenths for 10 hundredths. Then we could subtract 2 hundredths. Next, we subtracted 1 tenth. Then we subtracted all 6 of our ones. That left us with 2 tenths, 6 tenths, and 8 hundredths, so that's 20.68. Finally, we had 125.48, and we needed to subtract 72.3. We weren't subtracting any hundredths, so the 8 hundredths that was in our question stayed the same. We subtracted 3 tenths. Then we subtracted 2 ones. Next, we had to subtract 7 tens, but to do that, we needed to exchange our 100 for 10 more tens. So we can subtract 1, 2, 3, 4, 5, 6, 7 tens, and that leaves us with 5 tens, 3 ones, 1 tenth, and 8 hundredths. So that's 53.18. Now for these questions, we're subtracting a decimal from a whole number. So first, we have 5 minus 1.35. Now we can use column subtraction for this, but we need to be really careful and think about the place values in our question. Remember, the digit before the decimal point is the ones digit, so we have 1, 1, and the digits after the decimal point are the tenths and hundredths digit. So, when we're setting this out using column subtraction, we can write the 5, but then we need the 1 underneath the 5, so that our ones place value column is lined up. Now 5 is the same as 5.00. You can always write a decimal point and then zeros on the end of any whole number. And that doesn't change the number. 5.00 is the same as 5, so we haven't changed the question. All the .00 tells us is that in the number 5, we don't have any tenths or any hundredths. But now we can solve this using column subtraction. First, we need to remember to copy the decimal point down into our answer, and now we can solve it working from right to left. So first, we have 0 minus 5. We can't do that using the column method, and if we look to the left, we have another 0. So we need to go all the way over to our ones column, 1 less, 1 in front. So now we have 10 tenths, and we can exchange one of those tenths for 10 hundredths. So now 10 minus 5 is 5, 9 minus 3 is 6, and 4 minus 1 is 3. That gives us our answer 3.65. Now we have 8 minus 4.65. So again, I've written the 4 ones underneath the 8 ones that we're subtracting from. Remember, 8 is the same as 8.00. We copy the decimal point down into our answer, and now we can't do 0 minus 5, and we also have a 0 in our tenths column. So we need to go all the way over to the ones, 1 less, 1 in front, and now we do the same thing, 1 less, 1 in front. So now 10 minus 5 is 5, 9 minus 6 is 3, and 7 minus 4 is 3. That gives us 3.35. Now we have 11 minus 4.01. 11 is the same as 11.00. So now we copy the decimal point down into our answer. Again, we can't do 0 minus 1, and we can't exchange with the tenths, but we can exchange our 1 for 10 tenths, and then we can exchange one of our tenths for 10 hundredths. Now 10 minus 1 is 9, 9 minus 0 is 9. We can't do 0 minus 4, so go to the left, 1 less, 1 in front. 10 minus 4 is 6, and 0 minus nothing is 0. So that gives us our answer, 6.99. Now let's look back at this first question. We had 5, so that's 5 ones, and we needed to subtract 1.35. First, we exchanged one of our ones for 10 tenths. Then we exchanged one of our tenths for 10 hundredths. That meant that we could subtract 5 hundredths, then 3 tenths, then 1 whole, or 1 1. That gave us our answer, 3.65, so 3 ones, 6 tenths, and 5 hundredths. Then we had 8 minus 4.65. First, we needed to subtract 5 hundredths, but to do that, we had to exchange one of our ones for 10 tenths. Then we could take one of our tenths and exchange it for 10 hundredths. Then we could subtract 5 hundredths, then 6 tenths. Then we could subtract 4 ones. That gave us our answer, 3.35, so 3 ones, 3 tenths, and 5 hundredths. Finally, we had 11, so a 10 and a 1, and we needed to subtract 4.01. Again, we exchanged our 1 for 10 tenths, then took one of our tenths and exchanged that for 10 hundredths. We subtracted 1 hundredth. Then we didn't need to subtract any tenths, but to subtract 4 ones, we first had to exchange with our 10. Taking away 4 ones gave us 6 ones, 9 tenths, and 9 hundredths, so 6.99. Now in these questions, we're going to multiply decimals with hundredths by 10. But first, let's look at 5 times 10. You probably already know that the answer is 50, and you might have been taught that you can multiply whole numbers by 10 by just putting a 0 on the end. That works for whole numbers, but it doesn't work for decimals. So first, let's look at 5 times 10, but let's use the same method that we're going to use to multiply decimals. So first, we write the number out. And remember, there's really an invisible decimal point on the end of every whole number, so we can write 5 and then a decimal point. What we do is copy down the decimal point, and then we're multiplying, so as long as we multiply by a number larger than 1, the number gets bigger, so digits are moving to the left. And we're multiplying by 10, which has 1 0, so digits move 1 square to the left. So if we copy this 5 down, 1 square to the left, we know that the place value column before the decimal point is the ones column, and we can't have an empty ones column, so we need to write a 0. So now we have 50 and a decimal point at the end, so we have a whole number. 5 times 10 is 50. We can use the same method to multiply 0.5 by 10. So we write out the decimal and copy down the decimal point. Now when we multiply by 10, digits move 1 square to the left, so we can copy this 0 down 1 square to the left and do the same with this 5. Now we have 0.5 and a decimal point on the end, and if we have a decimal point on the end, we have a whole number, so we can just write our answer as 5. Because all this 0 tells us is that we don't have any tens in our number. Now we have 0.05 times 10. So again, we write the number out and copy down the decimal point. To multiply by 10, the digits move 1 square to the left. So if we copy the digits down 1 square to the left, we now have 0.5. Now we can't have an empty ones column, but we don't need this 0 telling us that we have no tens, so we can just write our answer as 0.5. Now notice our results so far. When we had 5 ones and we multiplied by 10, we got 5 tens. When we had 5 tenths multiplied by 10, we got 5 ones. And when we had 5 hundredths and we multiplied by 10, we got 5 tenths. And that's because when we multiply by 10, digits move one place value to the left, because when you have 10 of something, you have the place value to the left. So what is 0.09 times 10? Well, we write the number out, copy down the decimal point, and move the digits across one square to the left. So our answer is 0.9, because this 0 in our tens we can ignore. Now we have 0.43 times 10, so we write out the decimal, copy down the decimal point, and move the digits across. That gives us 4.3. So finally, we have 4.03, and again, to multiply by 10, copy down the decimal point, and move the digits one square across. That gives us 40.3. And it's really important that we include this 0 because it's in the middle of our number. If we didn't write this 0, the 4 would still be in our ones column, but we need to show that that's moved to the tens. So let's have a look at some of the questions that we did. We had 0.05 times 10. And we know that the second digit after the decimal point is our hundredths digit. So to show 0.05, we can show 5 hundredths, or 5 parts out of 100, on this rectangle. Now we also know that multiplying by 10 means making the number 10 times bigger. So if we shade 10 times as much of this rectangle in blue, you can see that we now have 5 tenths of this rectangle shaded. So that's 0.5. We also had 0.09 times 10. So that's 9 parts out of 100, or 9 hundredths. But again, when we make it 10 times bigger, we can see that we now have 9 tenths of our rectangle shaded. So that's 0.9, because the first digit after the decimal point is the tenths digit. Now for these questions, we're dividing whole numbers by 100. But, except for 400, the numbers that we're dividing by, so our dividends, are not multiples of 100. They're not numbers that are in the 100 times table. And that means that we're going to get decimals as our answers. So first, we have 4 divided by 100. So what we can do is write out the number 4 and then put a decimal point on the end, because remember, we really have an invisible decimal point on the end of every whole number. Then we copy down the decimal point. Now we're dividing, so the number is going to get smaller, because when you divide by any number larger than 1, your answer gets smaller. And we're dividing by 100, which has 2 zeros. So the digit is going to move 2 squares. So if we copy this 4 down, 1, 2 squares to the right, we now have some empty squares either side of the decimal point. But remember, the digit after the decimal point is the tenths digit. So we need to write 0 in here to show that this 4 is now in our hundredths place value column. And the digit before the decimal point is the ones digit, so we need 0 in here as well, because we can never have an empty ones column. So that gives us our answer, 0.04. Now we have 40 divided by 100. So again, we write out the number 40 with a decimal point on the end. We copy down the decimal point. We're dividing, so the digits are moving to the right, and we're dividing by 100, which has 2 zeros, so the digits will move 2 squares to the right. So if we copy this 0 down, 1, 2 squares to the right, and do the same with this 4, we get 0.40. But again, the digit before the decimal point is the ones digit, so we need to write 0 in here so that we don't have an empty ones column. So that gives us 0.40, but we don't need this 0 in our hundredths column, because 0.40 is the same as 0.4. All this 0 here tells us is that we don't have any hundredths, so we can ignore zeros if they're on the end of decimals. Now we have 67 divided by 100, so we write out the number with the decimal point on the end, copy down the decimal point, and move each digit 1, 2 squares across. We need a 0 in our empty ones column, and now that gives us our answer 0.67. Now we have 400 divided by 100. Now you might already know that the answer is 4, but let's use the same method that we've been using so far, just to show that it works. So with 400, we can write out the number and the decimal point on the end. We copy down the decimal point and move each digit 1, 2 squares across. That gives us 4.00. But remember, when you have a decimal point and then zeros on the end of a number, you have a whole number. So 4.00 is the same as 4. Now notice our answers so far. When we had 4 ones and we divided by 100, we got 4 hundredths. When we had 4 tens and divided by 100, we got 4 tenths. And when we had 4 hundredths and divided by 100, we got 4 ones. That's because dividing by 100 is like dividing by 10 and then dividing by 10 again, so the digits move 2 place values to the right. Now we have 399 divided by 100. We write out the number, copy down the decimal point, and move each digit 2 squares across. That gives us our answer, 3.99. Now 401 divided by 100, so copy down the decimal point, move the digits 2 squares across, and we get 4.01. And this time we need to remember to include this 0 because it's between other digits, so it's a placeholder. If we didn't write this 0, the 1 would be in our tenths column, but we need to show that the 1 has moved 2 squares across, so is now in our hundredths column. That's why we need a 0 in our tenths. Now notice, 400 divided by 100 was exactly 4. 399 is just a little bit less than 400, so our answer was just a little bit less than 4. And 401 is just a little bit more than 400, so our answer was just a little bit more than 4. Let's have a look at this first question. 4 divided by 100. So we have 4 whole rectangles, but remember, dividing by 100 is the same as just keeping one part out of 100. So we can show one part out of 100 on each of our 4 rectangles. But then, when we put these 4 parts together, we now have 4 parts out of 100, or 4 hundredths, of one whole rectangle. So that's why our answer is 0.04, because remember, the second digit after the decimal point is the hundredths digit. Now we need to multiply decimals by 100. So first we have 0.5 times 100. The way to multiply decimals is to write out the number, so 0.5, and then copy down the decimal point, so it's directly below. Then we're multiplying, so the number is getting bigger, and we're multiplying by 100, which has 2 zeros, so the digits are moving 2 squares to the left. So if we copy down this 0, 1, 2 squares to the left, and do the same with this 5, we now have 0, 5, and then an empty square before the decimal point. But we know that the place value before the decimal point is the ones place value, and we can't have an empty ones column, so we need to write a 0 in this square. That gives us 050 and a decimal point on the end. Now when we have a decimal point on the end of a number and nothing after it, we have a whole number. So our answer is 50, because we can ignore this 0 in our hundredths column. Next we have 0.04 times 100. So we write the number out and copy down the decimal point. We're multiplying by 100, so digits are moving 2 squares to the left. Now that's because in the number 100 we have 2 zeros, so digits are moving 2 squares. But it's also really because when we multiply by 100, we can think of that as multiplying by 10 and then by 10 again. And we know that when we have 10 of something, digits move to the place value to the left. So if we copy down this 0, 1, 2 squares to the left, do the same with this 0 and with this 4, we get the decimal point on the end of our number. So we have a whole number. Our answer is 4, because we can ignore zeros at the start of a whole number. We can ignore the 0 in our hundreds column and in our tens column and just show the 4 ones. Next we have 0.54 times 100. So we write the number out, copy down the decimal point and move the digits 2 squares to the left. That gives us the decimal point on the end of our number, so we have a whole number. That's 54 because we can ignore zeros at the start of a whole number. Now notice 0.54 is the same as 0.5 plus 0.04, and that's why our answer 54 is the same as 50 plus 4. What we've done here is the same as we've done in the previous questions, but instead of doing it one digit at a time, we've moved the 5/10ths and the 400ths in the same question. So now we have 5.4 times 100. Again, we write the number out, copy down the decimal point, and move the digits 2 squares to the left. But now we have an empty square before the decimal point, and we know that the place value before the decimal point is the ones column, and we can't have an empty ones place value column, so we need to write a 0 in this square. So now that we have the decimal point at the end, we know that our answer is a whole number, so that's 540. And it's really important to remember the 0 in the ones, because if we didn't have that, the 5 would be in our tens and the 4 would be in our ones. So we need the 0 to show that the 4 is 4 tens and the 5 is now in the hundreds column. Next, 5.04. So we write the number out, and to multiply by 100, we copy down the decimal point and move the digits 2 squares across, or 2 squares to the left. So now we have the decimal point at the end of our number, so our answer is 504. And this time, it's really important to remember to include this 0 because we need to show that the 5 is now in the hundreds column. If you have a 0 between other digits, we need to include the 0 in our answer. We can't ignore it. And finally, 50.4 times 100, we copy down the decimal point. In 100, we have 2 zeros, so the digits are moving 2 squares, and we're multiplying, so the number's getting larger, the digits are moving 2 squares to the left. Now we have an empty ones column, so we need to write a 0 in this empty square to give us our answer, 5040. Notice that this answer is 10 times bigger than our previous answer, and that's because 50.4 is 10 times bigger than 5.04. So let's have another look at this question, 0.04 times 100. Now we know that the second digit after the decimal point is the hundredths digit, So to show 0.04, we can show 4 parts out of 100 on this rectangle. But when we multiply by 100, what we're really doing is making the number 100 times bigger. So if we split up these 4 hundredths and make each one 100 times bigger, you can see that we now have 4 whole rectangles coloured in, and that's why our answer is 4. So here we have some missing number problems for multiplying or dividing by 10 or 100. And the way that we know that the missing numbers must be 10 or 100 is because if we look at the digits in our question, or at least the digits that are not 0, they're the same in the question and the answer. So for this first question, if we ignore the place values, we have an 8 and a 3, and in our answer we have an 8 and a 3. In this question we have an 8, and in our answer we also have an 8. So that tells us that we must have multiplied or divided by 10 or 100, or any value that has its own place value. So if you think to our place value columns, we have a tens column, we have a hundredths column, and also multiplying or dividing by 1,000 or any other place value column won't change the digits. That's because when we multiply or divide by 10 or 100, the digits move, but they don't change. So first, we have 8.3 times what is 830. Now the way I like to solve these is to write both numbers out, one below the other, but with the place values lined up. And the way that we make sure the place values are lined up is to copy down the decimal point. Remember, if we have a whole number, we really have an invisible decimal point on the end. So we can write 830, so our answer, with a decimal point on the end. Then we can see easily what's happened to the digits. So here we can see that this 8 has moved 2 squares across, and so have the other digits in our question. And when we move the digits 2 squares to the left, we've multiplied by 100, because 100 has 2 zeros, or because multiplying by 100 is like multiplying by 10 and then by 10 again. Next we have 0.08, so we can write out the number, and our answer is 0.8, so we can write 0.8 below with the place values, so with the decimal points lined up. Now here we can see that the digits have moved 1 square to the left, so that means the number has been multiplied by 10, because 10 has 1 zero, so digits move 1 square. Now we have 0.83, and we've multiplied to make 83, so we can write 83 with the decimal point on the end, so the decimal points are lined up, which means our tens, ones, tenths and hundredths place value columns are in the right place. Here we can see that the digits have moved 2 squares, which means we've multiplied by 100. Now we have some missing number division problems. Again, we know that the answer will either be 10 or 100, because if we look at the non-zero digits in the question, we have an 8 and a 3 in our dividend and an 8 and a 3 in our quotient. So we can write out the numbers one below the other with the decimal points, so with the place values lined up. And here we can see that the digits have moved 1 square to the right, and when we move the digits 1 square to the right, we've divided by 10, because that has 1 zero. Now 83 divided by what equals 8.3. So we can write out 83 and put our decimal point on the end, because it's a whole number, and then we can write 8.3 directly below with the decimal point lined up. Now we can see that the digits have moved 1 square to the right, so we've divided by 10. Now 83 divided by what is 0.83. We can write 83 and put our decimal point on the end, Then write the answer directly below with the decimal points lined up. We can see that here the digits have moved 2 squares to the right, and that means that we've divided by 100, because in 100 we have 2 zeros and the digits have moved 2 squares. Dividing by 100 is like dividing by 10 and then by 10 again, and that's why the digits move 2 squares to the right.